this video, I will be discussing more upon the different stages of NLP pipeline. So in the earlier video, we had seen the stages like how we can do the sentence segmentation by splitting the paragraph into sentence, and how we can make use of each sentence and split that into sentence into words or token. And then we are doing the POS tagging. That is your part of speech tagging on each token or the word. So let's continue our building the NLP pipeline. So the next stage is your text lemmatization. Okay, so the text lemmatization or the stemming. So these are the text normalization, or we can say word normalization technique in natural language processing. Okay, so these are used to prepare the text, documents, and words for doing further processing. Okay, so if we talk about lemmatization, then lemmatization, as we had discussed earlier also, it is used to reduce the form, form of the word to their basic form or the lemma. We call that word basic form as a lemma for each word. For example, if you have word like sentence like I had pony and I had two ponies. Okay, so the word ending with pony and ponies, okay, these two will reduce their base form, that is pony. Okay, so if you have two sentences that are talking about I had ponies and I had two ponies, so this pony will reduce to the base form of pony. Okay, so now in the two sentence, the number of occurrence of word pony is 2. Okay, and the number of occurrence word ponies there will be 0. Okay, so same thing will happen to all the sentences in the data. Okay, and when we go for calculating the frequency or the occurrence of words in each document, or number of occurrence of word in the complete or multiple document, then that will help to increase the number of occurrence of the word by reducing the or by removing the base form word, or by converting the word to their base form. So in the case of this sentence, the word is has been changed to be, that is the verb. So if you try to do the lemmatization of this sentence, so this sentence will convert into the this form. So is will reduce to be, and wherever you have the s in the uh, you know s or ly at the end, so that will be reduced to the base form. So next, let's see what is text stemming. Okay, so basically stemming is the process of reducing the inflection in the words. Inflection in the means the word that are ending with ly or ies. So it try to reduce those things, means it try to remove those things. So lemmatization try to reduce the words, but in stemming it try to cut the word, means completely delete those words. So in case of stemming, it reduce the inflection in the words to their root form. Okay, such as mapping a group of words to the same stem, even if the stem itself is not a valid word in the language. Okay, and the algorithm or the library that we use for doing text stemming is the Porter stemmer. So this is the widely used algorithm in case of doing stemming. So it is used to reduce the word to the base form or the stem. How stemming work, let's see. So suppose these words like lightweight, this will be reduced to lightweight. Natural, as you can see, this word is ending with al, so this will remove to al will remove, and it will left with natur. Okay, language will change to language. E will get reduced from this, and ing will reduce from this. So what stemming will do, it will cut the inflection form or inflection word from the word, and convert the word to the root form or the base form. So this will definitely give us the loss of information, because we are changing the actual word or to the some other meaning. Okay, so this will definitely reduce the language, this will definitely reduce the chances of getting accuracy at the time of doing some modeling with respect to text processing. Okay, and also it will give the uh, less weightage to the words. So that is the reason we mostly go for lemmatization when we do the text normalization. So this is a very basic example for the comparison between stemming and lemmatization. So in stemming, as you can see, their inflection form has been removed. This form has been completely removed from the word changed, or it is been left with word change. So chang, if you can see, so this word can also represent the name of the person, okay, or something else. But actual meaning, it is a change. It's something related to changing. But if you do stemming, then this word will meaning is changed, and also it will give us some different concept, or it may reduce the accuracy of our model. But if we do lemmatization, you can see the word change in the has been removed or reduced to the to their base form or to the lemma form, like so ing es. Okay, only s is removed from change, and only d is removed from change, keeping the base form alive or the actual meaning alive. So in case of stemming, your meaning of the word will change, and also it will give you the incorrect word. But in case of lemmatization, your actual word or the meaning will remain same. And only so these changer, these all will remove to introduce to word change. So this try to cut the word, and this try to reduce the word. Okay, so there is a loss of information in case of stemming. Okay, but there is a gain of information in case of lemmatization, because if in a document these words are occurring, so since doing the lemmatization, all these words has been reduced to the word change. So now the occurrence of the word change in the document will increase. That is 1 2 3 4 5. So we can say change has occurred in the document 5 times. Okay, but in this we can't say how many times that word change has occurred. Okay, so this is the very basic difference between stemming and lemmatization. Let's move further. So another is the removing the stop words. So what are the stop words? So words are the most occurring words in the document or in the sentence. So the words that are having less importance when we are doing some text analysis, or when we are driving the relationship from the text. Like in this input text, the words is, the, and, most, of. So these are the words that occur many number of time in the sentence, but these word doesn't give any contextual meaning or contextual strength to the sentence. So we use the stop word dictionaries that has been available with respect to various libraries like in NLTK Stanford. So we pass our each word into that stop word dictionary, and then our stop word dictionary will check that whether is available in their stop word dictionary or not. If that word is available, then in the sentence the word is will be removed. Okay, and the will also remove. So now we have the sentence that contains the word London, capital, popular city, England. Okay, also we have the facility to add your own custom specific stop word which you want to remove. Suppose if you want to remove founded from the document, from the data, so you can add founded into their dictionary. Now the sentence London is the capital and the most popular city will be, so the words is, the, and, most. So all these words will be removed from the sentence. Now we will left the only the important noun or context or the concept related words, like this. Okay, so now you can see as we are moving towards the creating, adding more stages to the our NLP pipeline, the our data shape is changing. Okay, means the length of the sentence is reducing, and more we are getting moving toward the concept or the meaningful information. Now there is another stage called dependency parsing. So this is one of the most important part of doing NLP processing of the text. So dependency parsing is basically used to determine how the words are related to each other in the sentence, or basically it try to check the structure, whether the sentence is grammatically correct or not. So we can check that using the dependency parsing. So what dependency parsing will do, it try to create a root tree, okay, using the top down approach. So in the top we have the root, okay, and then it tries to create the tree by linking the branches to the other words, like the word is dependent on the word London, okay, and capital, okay. Now for is the root, and is the parent of word root, London and capital, and capital is dependent on the word like the and. Okay, so as you can see, so this what dependency parser will do, it try to create a dependency tree which will create the dependency structure in order to determine which word is dependent upon which word and what is the type of that word. I mean, what is the part of speech of that word. So if word is dependent on the word London and capital, so let's check what is the type of POS tagging of this. So it is dependent on the noun, and another word is also noun, and they are linking with the help of a verb. Okay, so we can say that this, if we take only this part, okay, if we cut our tree from, if we take only this branch, so we will left with a sentence London B capital, and if we remove this word using lemmatization, then we will have a word like London capital. Okay, similarly, if you go down, you can see the word city is dependent on the words populous and most. Okay, so this hierarchy, this tree level hierarchy will help us to understand the tree pattern, or help us to understand the sentence structure, something like this. You can see, if you have, sentence is big, so your tree will grow more. So in the root you will have as S represent your sentence. You will have complete sentence over here. Okay. Then your sentence will got split into the noun phrase and the verb phrase. Okay. Noun phrase and the full stop. Full stop is your last token in the sentence. In the noun phrase, you will have the subclasses of noun, that is NNP, NNS, or NN. So in the NNP, you can see the word London, and in the verb phrase means it is talking about a phrase that contains the verb in it. So what is the verb? It is represented by the base class of verb is VBZ, that is, okay. And what is the verb phrase contain more? It also contains the noun phrase. So as you can see, if you go down, then you will have the tree in the form of noun phrase and verb phrase, and each phrase is will split it into the different branches. And in the leaf, that is your orange part is your leaf, and in the leaf you will have the actual value. So this noun phrase is split into two part. Another is your noun phrase and another is also your noun phrase. Why both branches are noun phrase? Because we have a conjunction in the middle of this. So as you can see, we have the determiner NN, that is with the. So whatever POS tagging we had done for the sentence, so based on those POS tagging, we have the dependency tree. So we can use this tree to extract the meaningful information, or also we can extract the noun phrases from it. Okay, like if we cut our tree from here, okay, and if we are looking to extract only noun phrases, okay, from this tree, so what information we will get? The first noun phrase is this, so we will have the information like the United Kingdom. Okay, if we look for more noun phrase, then we have the England and the United Kingdom. Okay, if we look for only this noun phrase, then we have the England. If we look for another noun phrase, then we can have the word most populous. Okay, if we look for another noun phrase, then we will have the capital London. So these are all the important information that we want to extract from the sentence. So we can extract those with the help of a dependency parse tree. Also we can check for the events also. What is actually, what event is binding the words together. Okay, like if you look for the adjective like populous, what is the populous? Most. So most is binding the word populous. Okay, Now, since we had built the tree, now what we are doing, we are extracting the noun phrases. Means we are extracting the phrases that we had highlighted in the red. So how we can do that? We can say London is the capital and the most populous. So the noun phrase that has been extracted out from this tree will be something like this: London, the capital, most populous city. How we how we can get this? By looking into the tree structure and checking that wherever we are getting NP, NP is your noun phrase. So we are only taking only that part from the sentence. Next is your named entity recognition. Named entity recognition is also the one of the important task in order to extract the meaningful information from the text. Named entity recognition determine the entities that is being identified in the sentence. So those entities are mostly belong to the category or the class of noun, like London. So London, what is London? London can be identified as a location. Okay. England is also identified as a location. United Kingdom can also identified as a location. Okay. Thames can also identified as a river name. Great Britain. So all these are the entities that has been identified in the sentence. Something like this. London is identified as a city. Okay. England can be identified as a country. And United Kingdom is also identified as a country. So this information is very helpful when we have large amount of text. So we once we had done the named entity recognition, then we will have the important list of entities that are available in the sentence, and we can, by looking into those entities, we can understand, okay, what is this document or what is this article is talking about. Next is co-reference resolution. So yes, co-reference resolution is basically used to check, if you have if you have used any co-referencing or not. Means if this is the sentence, okay, which is talking about London, okay, and then at after two sentences you had started by writing it, or you had written you, okay, or something that is been mentioning the previous entity. So this it can be referred to the word or the entity London. Means this it is referencing to the word London. So using co-reference resolution, we can give the references to the words where you had started your sentence with the word like it, okay, I, you. So you can reference those words with those entities, and once you have done the co-reference resolutions, for all those words, then you have the sentence that you can easily understand who is saying what. So finally, the NLP pipeline that we got after doing all the transformation is something like this. So initially we had passed some text document, then we done the sentence segmentation. We splitted the sentences into tokens or words. Then we had done the part of the speech tagging, where we had given the specific part of the speech to each word, whether the word is noun, pronoun, adjective, injection, determiner or not. Then we had done the lemmatization or stemming. We had done the stop word removal. We had created the parts tree. We had extracted the noun phrase, and then we done the name entity recognition. Finally, we done the core reference resolution. So this name entity recognition, noun phrases, so all these help us to store the data in the structured format. Okay, so like noun phrases are something like London capital, okay, uh, or something, name of the person, whether it's referring to some location or place. So all these words are, we don't have any group of sentences. Now we are only having a predefined set of phrases or words, so we can easily store those words based on the specific tag. Okay, like we can create a table, and in the table we can store the information, like in the data, what are the entities which are talking about the person. So in this we will store the all the names of the person, or what are the entities which are talking about the location. So we can store all the words that has been identified as the name of the location. So we can store this structured information, and we can make use of this information for doing any further analysis. So this is about the NLP pipeline. So I hope you guys will get basic understanding how NLP pipeline is, important in doing any text transformation or doing any text analysis. And in the coming videos I will be giving you the demo in which I will be doing all these tasks in the Python, and we will be trying to build various text summarization or topic modeling or sentiment analysis task using the NLP. Thank you so much for listening the NLP tutorial. I hope you will, after going through all these videos, you will get the basic understanding about NLP, and you can able to kickstart your career in NLP. Thank you so much.